So welcome to the next video in learning small components of our large language model. This time it is cross entropy. So we will see what that is. Cross entropy is a loss function. We all know we need a loss function. When we are training the model, every iteration it will have a prediction, and we also have the expected value or the label. So we need to have a mechanism to compare the label and the predicted value to quantify the loss. Welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we bring you hands-on demonstrations and insights into the latest tools and trends to help you get started with ease. Don't forget to subscribe and be a part of our journey into the future of technology. Such a function is called loss function, and such a loss function is used to decide the best parameters. And the process of iterating through these values is called gradient descent. So our aim is to reduce the loss and reach a stage where any additional variation in the parameters is beginning to increase the loss. Okay, so that is called gradient descent. So cross entropy compares the predicted probability distribution to the true label. And true label is usually one hot encoded. That is, only one of the class is 1. One of the output of the dimension is 1. Rest of the outputs are all 0. So cross entropy loss function tells us how close our predicted probability distribution is to the actual distribution or the true label. This is the function. Yi is the value of that specific class. It will be 0 or 1. And y hat I is the predicted probability value. And we take the log of it. And we add this across all the class or the entire dimension of the model. And what is the relationship between softmax and cross entropy? Before cross entropy, we have to apply softmax to convert the predicted numbers or normalize the predicted numbers into probability values, which adds up to 1. And then cross entropy should be applied. But remember, PyTorch applies softmax internally, so we shouldn't apply softmax on top of it, distorting the learning process. When are we using cross entropy? During training, softmax and cross entropy are applied together in the final output. And during inference, only softmax is used to get the class probability. We don't need a loss function, okay, because we are not training. Training part is over. Okay, so keep this as a handy reference for you to play with and learn it. Let's see how it works. Let me reset these to 0 and this to 1. So now here I'm giving just 5 dimensions to keep it simple. Original transformer paper had 512 and our GPTs have much more. But this is the idea. So these are the true values. So during training, of course, we have the label data. The next word is already known to us, and that is true labels. And this is one hot encoded. So only one value is 1. All the other values are 0. And when we do the prediction, we get the probabilities, right? And before calculating the probabilities, we apply softmax. Okay, we apply softmax and we get these probabilities. Okay, and that tells us which class is most probable. Okay, so in this case, after prediction, softmax finds that class 1 is most probable. That is the correct answer, right? So what should be the loss? It should be 0. See here. Now, if this is not that confident and other values have some probability, so these sliders don't add up to 1, so please ignore that part, but this is the idea. So this has got 0.9, so it is still a good prediction, but there is loss. So there is some scope for further improvement in the learning process, isn't it? So if you click, see, we have 0.66. So let's increase and reduce these. So remember, they all should add up to 1. That is not the case in this. I need to adjust the JavaScript code for it, but you're getting the point. So confidence level is low, See, this loss is increasing, and if this is 0, for example, error has become much bigger. I hope you will now remember cross entropy loss function really well. So if you have any ideas and questions, please give your valuable suggestions and questions in the comment section. Remember to like, share and subscribe. We will have many more tiny such videos where we can play and understand the internal workings of large language model and the transformer architecture. Thank you. Bye-bye.